Exponential equations. I'm going to teach a few new equations today. But first I'm going to review the two you've already seen. Exponential equations and where you have just one log. All right, here we go. I've got 49 x minus 2 equals 7. When you see an exponential equation, what do you always do? Say it loud. Say it louder.
Make the bases equal.
Say it so that you might remember it. Make the bases equal. Now, when you're taking the test a week from today and you don't even make the bases equal, there's no partial credit. Oh, I'm just used to scribbling something the teacher gives me half credit. No! I don't give you any credit unless there's a right answer down there. Okay? Partial credit. All right, so we make the bases the same. 7 squared, x minus 2, 7. And we get 7, 2x minus 4 equals 7. If you need it, put your 1 there. 2x minus 4 equals 1. 2x equals 5. And x equals 5 halves. Now, and there you go. So if you have a situation where you have exponentials, make the bases the same. All right. We're good with that? Give me a second to write and make sure you're thinking about it. If you got a question, ask me. All right. Now, making sure. All right, now, let's go ahead and let's look at problems where you have just one log that you need to work. I'm going to work problem number 25 right off the assignment. I just wanted to review that before I got to these. Okay, log base 5 of x equals 3. This is number 25. 25. Log base 5 of x equals 3. Ladies and gentlemen, as long as you just have one log, all right? As long as you just have one log like this, or as long as you just have one log on each side, you use rule number 5. Rule number 5. And what rule number 5 allows you to do is you put a 5 here and a 5 here. I'm using rule number 5. And that becomes x equals 5 to the third. X equals 125. Now, the reason I'm showing you how to get from here to here by putting the 5 here, 5 raised to log 5. If that were 7, what would you put here? 7, right? The reason I'm showing you this is I know in science classes, physics, chemistry, and all that, they just skip from here straight down to here. Okay? And if you ask them why, they just go, it works. But that's what they're doing. Okay? Everybody happy with that? Now, next little bit of knowledge. And this is before we start solving the really more complicated ones, but we're about to hit that next problem of work, but I want to show you a little bit of information. Okay. For right now, if we take logs, we need this number that works out in here to be positive. If we have a logarithm, this needs to be positive in here. Okay? Now, I'm going to try to give you an example and explain something without working a whole problem. All right. If I had this log 10 minus x, and I worked it out, maybe I'm looking at it on the ACT test and it's multiple choice answers, and I have the answer 10, I have the answer negative 10, I have the answer 4, and I have the answer x equals -4. And I'm looking at it, and they got it arranged in all these A, B, C, D answers and all that. And I want to just figure out which ones of them are possibly correct. Or which one of them I know can't be right. Somebody says, well, the -10 can't be right because what's in parentheses needs to be a positive. The ACT just set you up because you didn't listen to the rules. I didn't say this number has to be positive. I said when you put it in here in this parentheses, it has to work out to be what? Positive. Everybody get that? So that -10 actually works. That's a good answer. Because what's 10 minus a -10? 20. See this 10 right here? It won't work. Because you get log of 0. Can't happen. Yeah, because look, what would happen if you put 10 back in here? Get what? 0. Now, what would happen if you put a 4 in there? Ah, that would work. What would happen if you put a -4 in there? Ooh, that would work. So all three of those would be good solutions. You can't have it, when you finish working these problems that are a little more complicated, you're going to have to check your answers. And when you check your answers, you're going to have to make sure they have it to where you're taking the log of a what? Positive. Not that the x is positive, but that when you put it back in here, it has you taking the what? Log of a positive. All right? Now, as far as the log of negative numbers, you can't do it yet. Not yet. Okay? It's not that you can't do it, you just can't do it yet. It's like square roots of negatives. Okay? Now, to be honest, that equals pi times I. That's what natural log of -1 equals. It equals pi times I. But we're not doing any i's. All right? We're not doing those complex numbers. So for right now, always check your work. ACT tests, they have one like this on there. And it turns out that every one of the negative values works and none of the positive ones do, and everybody misses it. Okay? Because they didn't listen to the rule. All right. Now, we're going to look at how to work the actual equations. And I am going to go down and work number 27. 27. Here we go. 27. 27. I'll show you what to do when you have more than one log on a side. 27. 27. Log x plus log 4x equals 2. Now, you cannot use Rule 5 if you have more than one log on a side. Rule 5 requires you to have log, just one log at the most on a side. Okay? Everybody hearing that? One log at most. So what you do is you use Rule 6. Use Rule 6 and rewrite this. Log 4x squared equals 2. I used Rule 6. I combine that as a product. Is that all right? How many of you have your rules written down? Yeah, 'cause if you don't, do you get to use your rule sheet on the test? No. It's your brain and the test. Okay, what number is understood to be right here? Say it.
10.
10. Well, if there's a 10 understood to be here, I need to put a big old 10 right here. And put a 10 here. And I get 4x squared equals 100. No, you cannot use Rule 5 here. Won't work. Can't be done. X squared equals 25. X equals a positive 5 or a negative 5. Now, and folks, You can't use the -5. Why can you not use the -5? Because it'd have you taking the log of what kind of number? A negative. And then you have to do it with what right here? Taking the log of a what? Negative. All right? So, that one won't work. Let's see if the 5 works. That'd have you taking the log of a positive. That would have you taking the log of the positive, so it works. Always, when you're testing them, to make sure they're legitimate solutions, you got to check in the original. Checking for original, you got to check where to see if they're legit. The what? Original. These numbers, like this, are called extraneous. Extraneous solutions, extraneous numbers. They're the numbers that you get down there, but they really don't work. Okay? Or at least not within what we know yet. Okay, they don't work within what we know yet. Okay, now, looking here because I want to try to teach some of this. Let's look at 46. 46, I'll have to slide that down, but I want to look at 46. Okay, 46. Oh, no. 46. Thought there was a way to move this. 46. Don't cough on the children, Evans. I can still smell the, I test to see if I have COVID. I get a little espresso at Rhino Coffee on the way to school. I can give a plug for Rhino Coffee. It'll end up on the YouTube. Maybe my buddy that owns the place will give me some free coffee. But I can smell the espresso. You know, you get a shot of espresso. I don't have to drink it. It just smells so good. But you can smell the espresso. You can't have COVID. Best stuff in the world right there. Oh, I think I'm going to get noting after school. All right, log base 7. 3x plus 2 minus log base 7 of x equals log base 7 of 4. All right, folks, don't you dare try to use number 5 yet. You got to combine those two, right? Got to combine those. Can't use rule 5 until you have just how many logs on each side? 1. So you combine them. Log base 7. And is it okay if I just go ahead and multiply those together and get 3x squared? Ooh, you don't multiply those up because that's what? Subtraction, so it should be what? 3x plus 2. Oh, yeah, divided by x. Yeah, there's a minus sign there. So rule 7 says you should have the log of a over b.
And why couldn't we use rule 6?
Because rule 6 has a plus sign between them.
Oh.
Yeah, you got your rule sheet? Yeah, look at your rule sheet and make sure. Yeah. All right, then equals log base 7 of 4. Folks, you're going to put a 7 here. Right? Is that okay? So you're also going to do what? Put in what? 7 right there. Is that okay? And when you do that, 3x plus 2 over x equals 4. Then multiply both sides by x. 3x plus 2 equals 4x, and x equals 2. And then if you test the 2, it's okay because that would be positive, and that would be what? Positive. And after you write that, I want to ask you a little question about why I taught these 2 problems, or why I picked out these 2 problems. A lot of times, if you're taking classes and you're taking math, science classes, you need to think to yourself, why did the guy or why did the woman teach the problem that they taught? This one, I had all the log stuff, but what? It just equaled a whole number, right? This one, I had all the log stuff, but it equaled another what? Log. That's what makes those different. See, somebody says, well, why did you got it just a 4 here, but over here your 2 changed? Yeah, because it was what? 10 squared. Over here, it's 7 raised to log 7. All right? So that's, you need to think, why do we teach certain problems, or why is one problem a little different? Now, I'll be honest, the ones that have logs on both sides are usually pretty easy. Let's scroll down the page, see if there's anything better. You know, I want the afternoon classes to go, well, he never teaches us the stuff he teaches in the mornings. 48. 48 looks cool. Let's do 48. Yeah, 48. Let's do 48. That well, I've done 4 problems off of your work, and then you can redo them and see if you know how to do them. Okay, 48. Log base 12. There it is. 48. Uh, 48. Log base 12, x minus 2. Plus log base 12, x minus 1 equals 1. All right. You probably have already realized you must combine those 2 logs. Right? How many of you had already started doing that? You already knew you had to. Yeah. Now, you're going to have to multiply those together. X minus 2, x minus 1 equals 1. Okay, the correct term is distributive property. Now, some of y'all may use the word FOIL. All right? FOIL is a 4-letter word begins with F. You're not supposed to say that word. Okay? You're not supposed to say 4-letter words that begin with F. FOIL is not a word you're supposed to say. Everybody hear that? What's the correct term? Distributive property. Distributive property. Everybody say it. Yeah, almost, yeah. Don't use 4-letter words. FOIL is a 4-letter word. All right? Hear that, Miss Smith? Don't go home and get in trouble with your mom. Use the word FOIL in front of your mom. She'd be upset. Oh, no, she wouldn't, because she never came to class. She wouldn't even know. Okay, put a 12 here. Put a 12 here. And you get x squared minus 3x plus 2 equals 12 to the first. And any number raised to the first is itself. Then, if you see an x squared, you need to make it equal 0 and factor it. This is a trinomial. You're going to factor trinomials. X squared minus 3x minus 10 equals 0. Factors into x minus 5, x plus 2. And you get x equals 5 and x equals negative 2. And then you test them. Now, if you can't factor trinomials, I need to talk to your algebra 2 teacher and get your grade lowered. All right? Whatever grade. If you had above a C and you can't factor trinomials, we're in a little bit of trouble. Mr. Evans will help you factor trinomials. Stop by before school, stop by on Friday, or send me something on Friday, and I'll help you do trinomial factoring. I know some of y'all have learned this thing called slip and slide. Some of you learned this thing called the tree. I'm not going to make fun of those. They don't work very well. Come on, just learn to factor. All right? Now, put 5 in there. Works. Put -2 in there. It's not going to work because you're going to have log of a negative and log of a what? Negative.
What is that?
Sir?
What number?
Here to here? Oh, that's rule 5. Oh, you mean where you have to test them? That's not one of the rules. It's just right now we can't take the log of a negative number. Now, it's not that we won't be able to in the future, and you will do it in the future. You can't do it now. All right? So, here is our legitimate solution, and here is our extraneous solution. And there we go. All right? Now, if you look at this assignment that's on the board, you will notice that I have got problems circled. All right? The ones that are circled. Keep it because of the computer. I'd keep it. Okay. This is Sisson 5.5, and you need to work the ones that are circled. Work the ones that are what? Circled. Now, when you work the ones that are circled, there's an answer key right up here. He put a few of them as decimals. I think one of his grad students that was making out the answers for the back of the book was having a bad day. Or his wife is a computer science person, big brainy computer science person, and she may have let him think that decimals were okay. They're not. Now, I'm going to give you today to work and tomorrow to work on just these problems.